Every once in a while, life on Earth goes a little haywire. Whether it's because of comet impacts or volcanoes erupting all over the place, occasionally a lot of species go extinct all at once in what is appropriately called an extinction event. And in 1984, a group of scientists noticed that most of these events, both the big catastrophic ones, like the one that wiped out the dinosaurs, and the smaller kind of just bummer extinctions, happen just about once every 30 million years. The scientists didn't propose why this pattern existed, they just dumped their data on the lap of the astronomy community and basically said, "Have at it, science." Well, new research published last week by the Royal Astronomical Society seems to support one of the more recent theories about why extinctions happen. Maybe they're caused by dark matter. Okay, dark matter is a type of matter that doesn't emit or absorb light or any other kind of electromagnetic radiation, and thus it is very hard to look at it because of the whole not interacting with radiation thing. So nobody knows for sure what it's made of, but for the laws of physics as we know them to work, dark matter has to exist. That's because some objects, like galaxies, exhibit the gravitational effects of objects with much more mass than they actually have. So physicists theorized that there had to be some other kind of matter out there that they couldn't detect, hence dark matter. Now in 2013, a group of physicists from Harvard published calculations suggesting that a bunch of this dark matter might be sandwiched in the dense middle layer of the disk of our galaxy. And two physicists from this group proposed that this dark matter sandwich might have everything to do with Earth's extinction events. See, our sun takes 250 million years to orbit the center of the Milky Way. But it doesn't just orbit in a flat ellipse, it bobs up and down along the way in a wave pattern, and as it happens, it passes through this dense galactic disk every 30 million years or so. According to these physicists, it may be the dark matter in that disk that alters the orbits of comets, creating impacts on Earth that cause mass extinctions. And in this week's latest paper, Michael Rampino, a biologist at NYU, takes the idea one step further. He proposes that dark matter could actually accumulate in Earth's core as it passes through the galactic disk. Eventually, these dark matter particles would interact, annihilating each other and producing lots of energy that would heat up the Earth's core. This, he says, could explain the sudden ramp-ups in geologic activity, like massive volcanic eruptions that change Earth's environment enough that some species simply can't survive. So the dark matter extinction hypothesis does fill in some blanks, like why extinctions that weren't caused by comet impacts also fit the timeline. But so far it's all theoretical. While the calculations work, it can be hard to tell the difference between real causes and mere coincidence. If you gotta cash in your chips though, it's hard to think of a more impressive epitaph than "done in by dark matter." Moving on to the slightly more recent past, new research has found that a star might have paid our solar system a visit. Known as Schultz star, it may have passed as close as 0.8 light years from us as recently as 70,000 years ago. When the star was first discovered in 2013, a team of astronomers at the University of Rochester noticed something odd. It was speeding away almost directly from our solar system. Tracing its path backward, they realized that the star very likely passed right by us. Now, 0.8 light years is still pretty far away. That's more than 7 trillion kilometers, but it's still way closer than our nearest neighbor right now, Proxima Centauri, which is 4.2 light years away. Schultz's star is a very dim red dwarf, so even when it buzzed our solar system, it wouldn't have been visible to the unaided eye from Earth. But according to the calculations coming out of Rochester, it may have come close enough to pass through the Oort cloud, the comet-filled region at the edge of our solar system. And if it did, there's a slim chance that it could have interacted with some comets in that cloud, potentially slinging a few of them in the direction of the sun. Now, Schultz's star was probably too small and too fast to wreak much havoc, but if it did manage to kick some comets loose, they won't get here for another few 100,000 years, so I guess we'll have to wait and see on that one. But this discovery, just like the dark matter studies I mentioned earlier, shows that our solar system is indeed a very busy place. Thanks for joining me for SciShow Space News. If you want to keep up to date on all the latest space news and space stuff, you can go to youtube.com/SciShowSpace and subscribe.